Welcome to my class, that is class 12 physics chapter is ray optics, and in this class we will discuss about properties or characteristic of a image formed by a plane mirror. So many characteristics are there and we will discuss one by one. First characteristic, that is image formed by a plane mirror is always virtual. That is always virtual. And what is the meaning of virtual? Virtual means that is not real. That is not real. That means image cannot obtained on the screen. Image cannot obtained on screen. If image cannot obtained on the screen or image is not real, that is known as the virtual image. Clear? And we draw a diagram. Suppose this one is your plane mirror. This one is your plane mirror. Plane mirror means here two sides are there or two surfaces are there. This is the lower surface and lower surface is coated with silver. Lower surface of the plane mirror is coated with silver. And this one is the upper surface, and upper surface is the reflecting surface, and object is situated or source is situated always in the side of reflecting surface. This one is the reflecting surface. Clear? And suppose this one is the object, or that is the source. We write, suppose that is S for source, and we draw a incident ray. Suppose this one is the incident ray, first incident ray, suppose it moves towards the point O1. This point is your O1. That means that is the point of incidence. And an incident ray moves along this direction, and for incident ray we write that is I for incident ray. Then what happened? From point O1, again the ray return back into the same medium. So that for this, first here we will draw a normal. This one is the normal to the plane mirror. Normal means angle is 90 degree or perpendicular to the surface of the plane mirror, because this one is the surface, so that this is the normal, this angle is 90 degree. And you know this is the angle of incidence, angle between the incident ray and the normal, and with equal angle the ray is returned back into the same medium. So that the ray is returned back into the same medium with equal angle, and this is the reflected ray. This one is the reflected ray, and this is the angle of reflection. Angle of reflection is equal to angle of incidence, and for first reflected ray we write that is suppose R1. Clear? Then suppose another incident ray is also there, second incident ray. This one is the second incident ray. Suppose I meet at this point. This point means we write that point, we write suppose O2. Then what happened? Here also we draw a perpendicular or a normal to the surface of the plane mirror. This one is the normal, and for normal here we write O2 N2. For first normal we write O1 N1. And same thing here, this is the angle of incidence. With equal angle the ray is bounced back or return back into the same medium. So that we will draw the reflected rays, and this one is the reflected rays. This one is the reflected rays, and this is the angle of reflection. And a reflected rays here moves along this direction. This is the second reflected ray. This one is the first reflected ray. This one is the first incident ray. This one is the second incident ray. And look at the figure. Here initially this is the distance between the two reflected rays, and after that distance between the two reflected rays is gradually increased. If distance between the two reflected is gradually increased, then we say that these two reflected rays are diverging with each other. Diverging with each other means in this side both the reflected rays never cross with each other, because both are diverging. So that in this side both the reflected ray never cross with each other, so that in this side image cannot be formed. Then what happen? We extend both the rays in the backward direction. We extend first reflected ray in the backward direction. Clear? Similarly, we extend the second reflected rays in the backward direction, and both the reflected rays suppose meet at this point, so that image is formed at this point. This one is the position of the image. This one is the position of the image. And here in this figure, in the back side of the mirror, no light is there, no rays are there. And these rays are not real rays. And here, both the reflected ray appears to meet at this point, so that these two rays are not real. So that image is also not real. Image is virtual. That means simply we say that if object is a real one, then image is virtual. In case of a plane mirror always formed virtual image if object is real. Another characteristic is there. Second characteristic, image is always erect. Image formed by a plane mirror is always erect. What is the meaning of erect? Erect means not inverted. That is not inverted. Clear? That means upright. If not inverted, that is known as the erect. Suppose we take two pens. First one, this one is your object. Suppose this is the head, this pointed, that is the head, suppose. Similarly, this is the suppose image of this object. Then this one is also head, head of the image. Then here, head of object and head of image both are situated in upside, not in downside. If image is formed, suppose this one is the image of this object. If image is formed just like this, we say that this one is a inverted image, but this one is not inverted. Not inverted means that is erect. And look at also figure. Suppose this one is the object. And this is the head of the object. This one is the head of object. For object, here we write suppose O. Similarly, suppose this one is the image of this object, and here also head of the image is this one. If situation is just like this image is not inverted. So that we write this is the image, and that one is the erect image. Erect image means not inverted. If situation is just like this, image is formed just like this. This is the head, this one is the head, this one is the head of the image. Then we write this one is the inverted image, but this one is the erect image. Clear? That is the difference between erect image and inverted image. This one is the inverted image and this one is the erect image. That means if image is virtual, that is always erect. And here also we draw a figure. And suppose this one is the surface. And this is a plane mirror. That is perpendicular to the surface. And same thing here also, two sides are there. This is the back side. Back side is coated with silver. And this one is the front side of the mirror. Front side of the mirror means this side is your reflecting surface. This side is the reflecting side. That means object is situated always in this side. And here, suppose this is the position of the object, and for object we write that is AB. For object we write that is AB. AB is the height of the object, suppose. And this one is the head. This one is the head of the object. This one is the head of the object. Then what happens? From point B, suppose we draw two incident rays. This one is the first incident ray. First incident ray is perpendicular to the surface of the plane mirror. And at this point, what happened? The ray is returned back in the same path, because this is the incident ray. And at this point, first we draw a normal. This one also normal. So that your normal and incident ray both are parallel. This is the normal to the plane mirror, because this one is your plane mirror, this one is the plane mirror. So that this one is the normal, and incident ray situated on the normal. So that angle between incident ray and the normal, that is 0 degree. Your angle of incidence is 0 degree. Then the ray is returned back into the same medium and in the same direction. Here incident ray and reflected ray, and normal, both are all are same. That means this is the incident ray and this one is the normal, and the reflected ray return back in the same direction. Clear? And your angle of incidence and angle of reflection both are 0. Similarly, we draw another incident ray, second incident ray towards the mirror. Suppose this one is the second incident ray, meet at this point. Then what happens? Here we draw a normal or perpendicular to the surface of the mirror, because this angle is 90 degree. This angle is 90 degree. Then you know this angle is the angle of incidence, angle between the incident ray and the normal, and with equal angle the ray is returned back into the same medium, so that the ray is returned back into the same medium in this direction. And this is the second reflected ray. This is the second reflected ray. This one is the first reflected ray. This one is the first incident ray. This is the second incident ray. Clear? And look at the figure. The distance between the two reflected ray is gradually increased. If distance between the two reflected ray is gradually increased, then here also both the reflected rays are diverging with each other. If both the reflected rays diverging with each other, these two reflected rays never cross in this side, never cross with each other in this side, or never meet with each other, so that in this side image is not formed. Then what happens? Same thing, we extend both the rays in the backward direction with a dotted line. We extend both the rays in the backward direction. This one is the first reflected ray and we extend in the backward direction. Second reflected ray, here also we extend in the backward direction. And both the reflected rays after extension in the backward direction meet at this point. And this is the position of the image. Image is formed at this point. And draw the image. This one is the image. This one is the image. And here, head is situated at the same side. Head of the image is situated at the same side of the object. Clear? Suppose this one is the head of object. This one is also the head of the image. Head is not inverted. Head of the image is not situated in this side. Head is situated in this side. That is not inverted. Not inverted means that is erect. Clear? That means always image formed by a plane mirror, image of a real object. This one is the real object. Real object after reflection gives a erect image. Clear? After reflection from a plane mirror always gives a erect image, or that is also known as the not inverted. And here look at the figure. Here AB, that is another property. AB. Next property, AB is the height of the object. For height of the object, we write O. A to B, this is the height of the object or size of the object. That is, we write O for object. Similarly, for image, we write A1, B1. That is the size of the image. We write A1, B1. That is the size of the image. Size of the image, we write that is I. I for the size of the image, capital I. And look at the figure. Here AB is the same as A1, B1. AB means height of the object is the same as height of the image. That means both are same size. Both are same size. Both are same size. In case of a plane mirror, height of the object is the same as height of the image. Clear? This is the third property or third characteristic of an image formed by a plane mirror. And another characteristic. Next characteristic, that is fourth characteristic. Always image formed by a plane mirror is laterally inverted. What is the meaning of laterally inverted? Meaning of laterally inverted means, suppose one example is there. Suppose if we stand in front of a mirror and we raise our left hand, then what happens? We feel that our image raise its right hand. If we stand in front of a plane mirror and we raise our left hand, then we feel that our image inside the plane mirror raise its right hand. But our head always situated in upside. Head is not inverted, but simply our left hand, that is the object, we feel our image raise its right hand, and that is known as the laterally inverted. Clear? Similarly, another example is there. Second example, suppose a plane mirror is there. This one is the plane mirror, and here also two surfaces are there. This is the coated with silver back surface, and front surface is the reflecting surface. So that object is situated in this side, and we write suppose in front of the mirror, we write suppose that is pen. This is the letter P, this is E, and this one is N, pen. Then after reflection through the plane mirror, what happened? Here this line after reflection looks like just like this. Clear? And this line of N after reflection looks like just like this. And this line of the N looks like this. That means suppose N is the object, and image of N looks like this. Similarly, here E, this line, this one line, second line and third line, they looks like this. This one is the first line of E, second line and third line, and this line of E looks like just like this. Clear? That means E after reflection looks like this one. This is the image of E. Similarly for P, this one looks like just like this, and the straight line of P looks like this, and this is the image of the pen. That means here image formed by a plane mirror looks like this. So that is known as the laterally inverted, because this one is the head of a P, and this one is the head of a P. This is the object, this one is the image. So that head of both object and image is in the upside. So that is not inverted. Not inverted means that is erect, but laterally inverted. Clear? Laterally inverted means here, suppose this is the left of the object means that is P situated in the right of the image. This is the right of image. This is the right of image, and this is the left of object. That means left of object is situated in the right of the image. Similarly, this one is the right of the object. Right of the object is situated in the left of the image. If right of object situated in the, if the left, this one is the left. If left of object situated in the right of image, and the right of image situated in the left side of the image. If right of object situated in the left of the image, that is known as the laterally inverted. Clear? That means image formed by a plane mirror is, that is virtual. Second one, that is erect. Third one, both are same size, and fourth one, laterally inverted. And the last one, last property. That means suppose this one is your plane mirror. An object is situated at this point, and this is the distance between the plane mirror and the object. So that this distance is known as the object distance. This distance is known as the object distance, and its image is formed in the back side of the mirror. And suppose this is the position of the image, and this is the distance of the image. That means distance of image is always same as distance of object. Distance of image is always same as distance of object. In case of a plane mirror, we write distance of object from a plane mirror is equal to distance of image from a plane mirror. And for distance of object, we write the symbol u, small u. Always we write that is a small u. Similarly, distance of image from the plane mirror, we write that is v. That means u is equal to v, always. And here also same thing. We will draw a diagram. Suppose this one is your plane mirror, and a lower surface, that is coated with silver, and your upper surface means this side is a reflecting surface, and this is the position of the object. For position of the object, we write suppose that is O, that means source is situated at this point. And here also two incident rays are there. This one is the first incident ray, moves normal to the surface of the plane mirror, and this one is the second incident ray. Two incident rays are there, and first incident ray is normal or perpendicular, and this one is the second incident ray. And for incident ray, here also write I. Then what happened? We draw the normal at this point. This one is the normal. This one is your normal to the surface of the plane mirror. And here in the first case, what happened? This one is the incident ray, and this one is the normal at this point. At this point means at point O1. That means normal and incident ray both are same. So that angle of incidence is 0. If angle of incidence is 0, angle of reflection is also 0. So that the ray is returned back in the same path. Path is same, but direction is opposite. Because incident ray moves towards the plane mirror, reflected ray moves away from the plane mirror. Both the rays situated on the same line. Clear? Then in the second case, what happened? This is the angle of incidence, and with equal angle, the ray is returned back into the same medium. So that this is the reflected ray, and here we write this is the angle of incidence I, this one is the angle of reflection R. For reflected ray, this is a second reflected ray, we write that is R2. Clear? Then same thing here. Distance between both the reflected rays is gradually increased. If distance is gradually increased, both are known as diverging, and we extend both the rays in the backward direction with a dotted line. we extend first reflected ray in the backward direction. Similarly, we extend the second reflected ray in the backward direction, and both the reflected ray suppose meet at this point. Both the reflected rays suppose meet at this point. That means here image is formed. This one is the position of the image. For image we write that is I. For image that is we write I. And look at the figure. Look at the figure. Here this angle is I. This angle is I. And this line both are parallel to each other. These two lines parallel to each other. If this angle is I, this angle is automatically I. Clear? That is not the alternating angle. If this angle is I, this angle is I. Similarly, look at the figure again. This line is parallel to this line, so that this line meet this line with angle R. If this angle is R, this angle is also R. And you know, from the laws of reflection, you know, angle of incidence is equal to angle of reflection. That means here two triangles are there. Suppose this is the second point of incidence, we write O2. Here two triangles are there. First triangle, that is O1, O2, O1, O2 triangle. This is the first triangle. And second triangle, that is suppose I, O1, O2 triangle. I, O1, O2 triangle. Two triangles are there. And we compare these two triangles. If we compare these two triangles, look at the figure. This angle is I, this angle is R. And from the laws of reflection, this angle and this angle both are same. Similarly, this angle is 90 degree, this angle is also 90 degree, so that these two angles are also same. Then third angle of the first triangle same as third angle of the second triangle. And here also O1, O2, this side is common to both the triangles, so that these two triangles are similar with each other. These two triangles are similar with each other. If these two triangles are similar with each other, finally we write this side of the first triangle is the same as this side of the second triangle. This side means we write that is O1O is equal to this side means that is O1I. That is O1I. What is O1O? O point, that is the position of the object, so that distance of object from the plane mirror, this distance that is known as the object distance. And for object distance we write that is U is equal to, similarly, this is the position of the image and this is the distance of the image from the plane mirror, and this distance that is known as the image distance. For image distance we write that is V. Clear? That means always distance of image from the plane mirror is the same as distance of object from the plane mirror. And these are the properties or characteristics of a image formed by a plane mirror. Clear? And in the next class we will discuss about rotation of a plane mirror. And thank you.